Hello everyone. Today we are diving into forces and loads, another two fundamental concepts in mechanical engineering and structural design. Understanding these helps engineers design stronger, safer and more efficient machines. Not only machines but also to build stronger, safer and more efficient vehicles and buildings. Let's break it down. What is force? A force is any action that causes an object to move, stop or change its shape. The basic formula for force is m into A, where F is the force, m is equal to mass in kilograms or grams, A is equal to acceleration, most probably meter per second square. For example, when you push a car, you apply force to make it move. When you press a brake pedal, a force slows the car down. Even gravity is a force. It constantly pulls everything towards the earth. What are the types of forces in the engineering? How are these different types of forces affecting the structures and the machineries? The first is tensile force, pulling or stretching force. Example, the suspension cables in bridges. Next commonly experiencing force is the compressive force, which is this squeezing force. Example, pillars holding up a building. Then could be the shear force, sliding forces that acts parallel to a surface. Example, scissors, cutting paper. Torsional force, which is also called as twisting force. Example, a car's crankshaft rotating. Bending force, a combination of tension and compression. Example, a beam bending under weight. Now, what is load? A load is a force applied to a structure or object. Loads determine how materials are selected and how designs are structured. The main type of loads include 1. Static load, a constant force over time. Example, a parked car on a bridge. 2. Dynamic load, a force that changes over time. Examples, vehicle moving on a road. Impact load, a sudden force. Example, a hammer striking a nail. And then cyclic load, repeated loading and unloading. Example, aircraft wings experiencing pressure during flights. Understanding these forces and loads helps in different ways in different types of industries. For example, in automotive industry, designing suspension systems to handle road impacts. On aerospace industries, this ensures aircraft wings withstand the fluctuating air pressure. In civil engineering industries, this helps in calculating the bridge strength to support static and dynamic loads. In manufacturing industries general, designing gears, bolts and machine parts to resist the wear and tear. Why these understanding forces and load is important? Engineers must consider forces and loads to ensure structural safety and prevent failures. These optimize material selection for lightweight yet strong designs. These improve durability and longevity of mechanical systems. And that's force and loads explained. Whether it's a car suspension, an airplane wing or a bridge, these concepts are critical to safe and efficient design. Thanks for watching and stay tuned for more engineering insights.